What's up, guys? This video is going to cover the Karel the Dog Maze, which I created and added to our unit. We're in a maze. We're trying to find the treasure, the ball, sometimes by moving, turning, combination, or a little more until the end where any of the normal approaches are going to find themselves stuck in a loop, going in circles, and requiring something a little bit special to shake them loose. In class, we had some great discussions about what that might be, and I'll mention them here and show an example. Let's get going. What I always recommend in any problem is getting from 0 test pass to 1, because if you can get to 1, then you know I'm using the right language with the right syntax, I got the right function name, I know what the goal is, all of those basic things. Even when it's as simple as a word. Now I know I get to the ball. If I was thinking in the back of my head, should I pick it up? Now I've got my answer. No, I shouldn't. Little things like that are a big help. So what do we have for the next one? Well, sometimes we got to turn and sometimes we got to repeat. These are the things we've learned in this unit, conditions and loops, right? So let's do it. If left is clear, and by the way, I could choose to prefer right as a default, but of course in this map it makes sense to go left. And look, the red squiggle is telling me I forgot the parentheses. If left is clear, we'll lean that way. And then whether or not we did, we're going to move. See what I mean about the red squiggle? If you hover over it, it gives you a little hint. Thank you, parentheses expected. I always do forget that, so it's nice for a reminder. Now, of course, if I run this, it's not going to help. We're not actually solving it yet. But it is a good test, because even though we got the help from the editor with the highlight and the red squiggle, it didn't include everything, and it might not have told us if we missed a bracket, for example. Hitting run would. It would tell us a lot more in the form of error messages. So it's good to do as often as you can. But what we actually need here is some way to repeat. And what have we seen so far? We've seen for loops, probably not the best here. While loops, totally fine. Or we've seen functions, and if you have a function call itself, that can repeat. But they didn't use that officially in the unit. Let's say while we haven't hit our goal, we'll do the thing. Now this is probably the opposite of how you'd say it in English. In English you'd say until we do, we keep going. I don't know of any programming languages that have the word until, but they all have while and they all have not. And if you combine those, you got it. Now if I run this, look at that. If I run this, uh-oh, we're stuck in a corner. If I run the third one, stuck in a corner again. So it looks like we're going to have to do the one thing we haven't done, which is turn right. Let's throw that on the end. See what happens. Hey, we got out of that dead end. We got out of that corner. Let's go back to the spiral one and see if we are still good or if we ruined it. All right. Hey, look at that. 4 out of 5. So we must be passing the fourth one too. Even though it visits literally every other spot before the ball, it does get there, and it does get there in an intelligent way. Great. Now you might be thinking, we're intelligent, we're geniuses, we've solved it, until you realize, no, the last one has a problem. We solve the corners and dead ends by relying on corners and dead ends, and so if we never find the right kind of corner, and we never find the right kind of dead end, we never get a clue to change our ways, and we just get stuck like this. So what are we going to do to get out of that? Well, first I'm going to show something wrong, but it's going to be kind of helpful, and we'll build up from there. When I asked in class, how do we break out of this loop, a lot of people said, remember where we've been, keep track of every spot. Which, by the way, is not enough. You'd have to keep track of every spot and direction. But that would work. we haven't learned how to do that in JavaScript yet, but if you kept an array or a map of all the history, then you could check if we've been here before, and going again would just bring us back, right? And then you could change the next time we have a choice. Maybe you could do it in the dog universe by putting balls and saying like 2 balls means I was north when I was here and 3 means I was east or something, but that seems like a lot of work. Instead, I'm going to show a different way based on what if I just write the thing that would solve this one. So one thing that happens a lot is people just add more specific cases like, oh, if we're here and if we have this and this, then do this. And they kind of go off the deep end. But let's do a simple one. If right is clear, take it and go down that path, okay? And if you do that, it actually does work for this maze, but it fails for the other ones because it messes up their algorithm, right? So what's the deal here? Well, what we need to do is to say, sometimes do this, right? That's the other path. Instead of remembering where we've been, the other path is just like, shake it up a little bit. Like sometimes you do left, sometimes you do right when you're at a crossroads. And I showed one way, which was the favorite of CodeHS. For whatever reason, they love using the modulo operator to do even, odd, and things that are on cycles. And I showed one version with that where we do like every 7 moves, you take the other direction, or every 13 moves. I think it has to be a prime number. But then we realized there's an even simpler way, which is pure random. What if we just say 90% I'll lean left, 10% I'll lean right? And we have access to that. So let's put a little comment that says most of the time prefer left, but, you know, every once in a while prefer right. And so this would mean that if we're in a circle, going in a loop, we're going to hit both flips of the coin, both rolls of the die, you know, just like, maybe not this time, but keep going, we'll get it. So what we're going to do is to say, okay, JavaScript has a thing called math, which offers the kind of functions you might see on a calculator, like square root, absolute value, distance between 2 points, that kind of thing. But it also has one called random. And math.random gives you a number between 0 and 1, some long decimal that's like 0.24896 blah blah blah, or 0.99348 blah blah blah. So if you want to do something a certain percentage of the time, you can just say if it's, you know, if it's less than 0.1, that would be 10%. Where did I get 10%? Nowhere, I just made it up, but it's going to be fine. How do we combine the two conditions? If I want to say this and this, well, I could put one inside the other if, and then do another if, but most programming languages have an and, which is the way to combine two conditions. There's or, which means either one. There's not, which means flip one. But and is a way to say if this is true and this is true, not neither, not just one, but both. JavaScript does it with the double ampersand, which is the little guy on the 7 key. So when I run this, it might look the same because it's only 10% of the time and right is clear, so it's a lot less than 10% of the time, really. It'll do a different move. And if we run this over and over, we won't notice any difference on this maze. But we might on some of the other ones. You might notice this one going back and forth a little bit in the middle. Or this one might make an extra move. Actually, this time it got lucky and it made an accidental turn toward the goal and did it faster than it would have. Whereas right here, we're going to see what goes on. It's probably going to loop a few times and then change, but it might get lucky and do it right away. Not bad. Every time I run, it's going to be slightly different, and this time it's really getting unlucky and it takes a while. But you can see that we're basically guaranteed to land there after running this for a while, but we can't say when. So we're not guaranteed to like do it in 23 moves or something. It's just eventually. And I've gotten unlucky, and these last couple have taken a while, but you'll see that they're still safe and they'll still get there, which is kind of silly, but it works. Now, what do we do in real life with that? There are some functions that use randomness in real life. Maybe you're generating a password and you need it to be unique and different. Or I've seen some stuff that involves timing, like if I connect to a server, somebody else does at the same time, and it needs to be just one, then we can't wait a predetermined amount, because if I do it and the other guy does it, the conflict remains. So instead, they'll throw in a little a random amount of milliseconds, and then we'll land at a different time with no conflict. So I thought this was a fun little problem. Of course, it's slightly new and they haven't covered the random stuff yet, but the idea of shaking it up and doing something a little bit different is great, even when the outcome is guaranteed. We know for sure it's going to get there. We just don't know exactly how. And inside of that, which covers the idea of abstraction, inside of that might be a little different. So see what you think. Let me know if you have a question. And definitely let me know if you think of other ways to do it, of which there are many. See ya.